Welcome. Tonight we drift toward the oldest question there is. What came before the very beginning of everything? There is nothing to solve and nothing to remember. Let the wondering be soft and let it carry you towards sleep. We will move slowly through real science and honest mystery, the way the cosmos itself moves, without hurry, without alarm. Each idea is a small light in the dark, offered only to ease your mind toward rest. You do not need to follow every thought. Let the words wash over you like a calm tide. Some ideas are well tested, some are still only beautiful guesses, and all of them are safe to fall asleep inside. Tonight's journey reaches back through the expanding sky, past the first light, to the edge of what anyone knows, and then a little beyond, into the gentle dark of the deepest question. So settle in. Let your breath slow and your shoulders ease. The universe has waited billions of years for this quiet moment, and it is in no rush. Neither are you. Long before telescopes, people looked up and wondered how it all began. The question of what came first may be the oldest one our species has ever held, whispered under countless quiet skies. Every culture has told a story of the beginning. Tonight we tell the one written in starlight and measured by careful science, a story still being read, line by line from the sky above us. The wonderful thing is that the beginning left traces. The universe kept a faint record of its own first moments, and we have only recently learned how to read a little of it. And yet the deepest part of the question stays open. What came before the beginning is a place our instruments cannot yet reach, and that unknown is not frightening, it is simply vast and calm. So we hold the question lightly, the way you might hold a smooth stone in the dark. It asks nothing of you tonight except that you rest, and let the mystery keep you company. Here is one of the surest facts we know. The universe is expanding, the distant galaxies are easing away from one another, and the space between them grows a little more with every moment. It is not that the galaxies fly outward through space like sparks. It is space itself that stretches, gently carrying everything along, the way dots on a balloon spread apart as the balloon fills. Nearly 100 years ago, careful watchers found that the farther a galaxy lies, the faster it recedes. That simple pattern was the first clear sign that the whole cosmos is slowly swelling. This stretching is calm and steady, far too slow to feel. Yet across the great dark, it carries galaxies apart at a pace that gently reshapes the entire sky over billions of years. And expansion has a hidden gift. If everything is spreading apart now, then long ago it was all closer together, a clue we can follow backward toward the beginning. Imagine the history of the cosmos as a long, slow film. We can run it backward in our minds, watching the galaxies draw nearer instead of farther, the whole sky gathering inward. As we rewind, the universe grows smaller, denser, and warmer. Everything that is now spread across billions of light years was once pressed into a far tighter, far hotter state. Keep rewinding, and the warmth becomes a glow, then a fierce heat, then something hotter than any furnace. The early cosmos was a sea of light and energy, smooth and bright. Run the film back far enough, and the galaxies, the stars, even the atoms have not yet formed. There is only a dense, glowing fog expanding and cooling toward the world we know. This rewound history points toward a single beginning roughly 13.5 billion years ago, the hot, dense start that we have come to call the Big Bang. The name can mislead. The Big Bang was not a blast that tore through empty space, scattering matter outward from one spot. There was no waiting room of space for it to explode into. Instead, the Big Bang describes the whole universe in its earliest hot, dense state, and the steady stretching of space itself that began from there. The bang was everywhere at once. Every point you can imagine, including the very place you are resting now, was part of that early density. The beginning did not happen somewhere far away, it happened right here and everywhere. So the universe did not expand into a void. The void, in a sense, expanded along with it. Space, time, matter, and light were all woven into the same unfolding. Held that way, the Big Bang feels less like violence and more like an opening, a vast, smooth beginning that has been easing outward in silence ever since. In its first stretch of time, the universe was too hot for atoms to hold together. It was a brilliant fog of particles and radiation, glowing far brighter than the inside of any star. Light could not travel freely in that fog. It scattered endlessly among the dense particles, the way a lantern's glow is trapped and smeared inside a thick bank of cloud. So the early cosmos was luminous but opaque, full of light that could not get out, a glowing sea pressing against itself in every direction at once. As space expanded, this sea cooled. Slowly the fierce white heat softened toward orange, then deep red, the whole universe dimming like an ember left to settle in the dark. That cooling set the stage for everything to come. From a smooth ocean of light, the first calm structures of the cosmos would begin in time to take shape. There is a limit to how far we can look, and it is not the edge of the universe, it is simply the distance light has had time to cross since the beginning. Beyond that horizon, there may be far more cosmos, perhaps endlessly more, but its light has not yet reached us. We see only the portion the years have allowed. This horizon is a little like standing at sea. The ocean continues past where you can see, but the curve of the world hides the rest. The universe has a curve of time instead. As the ages pass, our horizon slowly widens, and a little more of the ancient light arrives. The visible universe is a growing circle drawn by the speed of light. So when we ask about the beginning, we ask about the deepest edge of that circle, the oldest light, arriving now after a journey of nearly 14 billion years. We can trace the universe back with great confidence almost to its very first instant, but the moment of the beginning itself and anything before it lies past the reach of our equations. At that extreme, our two best theories of nature stop agreeing with each other. The science of the very large and the science of the very small both speak, and they do not yet speak as one. So the question of what came before is not closed by stubbornness. It is open because we have honestly reached the edge of what current physics can say, and we know it. That honesty is part of the beauty. Science is comfortable saying we do not know yet, and treating that unknown as an invitation rather than a wall. Tonight we will walk right up to that edge together, look gently over it, and rest in the calm fact that some of the largest mysteries are still ours to wonder about. There is a soft comfort in a question this large. It does not need you to answer it. It has waited since the dawn of thought, and it can wait a little longer while you sleep. Tonight you are not solving the cosmos. You are only its guest for a quiet hour, free to drift among its ideas the way you might wander a still garden after dark. The universe holds no urgency. It has spent billions of years easing outward, in no hurry to be understood, content to simply unfold. Let that calm settle into your breathing. If a thought tonight seems too big to hold, let it go. The next gentle idea will come along on its own, like a slow current carrying you toward rest. So we begin our walk back through time without worry. There is only wonder ahead, and sleep waiting at the end of it, soft and certain as the dark. Let us pause and simply drift for a moment. No new ideas now, only the slow widening dark and the soft sense of galaxies easing apart across the silent sky. Breathe in slowly and imagine the gentle stretching of space, carrying everything outward without effort or sound, a motion older than the earth itself. Breathe out and let a little of that vastness loosen your shoulders. There is so much room in the cosmos, and a little of it is yours to rest within tonight. When the early fog finally cooled enough, light was set free for the first time. That ancient light is still traveling, and it still washes over the earth tonight, faint and everywhere. We call it the cosmic microwave background, the afterglow of the beginning. It is the oldest light there is, released when the universe was only a few 100,000 years old. It fills the whole sky in every direction at once, a soft sea of radiation so gentle it took clever instruments to notice it. In a strange and lovely way, the beginning is not only behind us, its glow is around us right now, passing through the room, through you, on its long, quiet journey. To rest tonight is to rest, bathed in the faint warmth of the first light, a glow that has been crossing the cosmos since long before the earth or the sun were born. The idea of an expanding universe with a beginning did not arrive all at once. It grew slowly through the careful work of a handful of thoughtful minds. One was a quiet scholar who realized that the equations of gravity allowed a universe that grows, and who first proposed that it began from a single dense start. Another measured the distant galaxies and found them receding, giving the growing universe its first firm footing in observation rather than theory alone. Later thinkers asked whether time itself began, sketched the no-boundary idea, and imagined bounces and many universes, each adding a soft new line to the story. So the picture we hold tonight is a gift from many hands across a century, each one passing the great question gently onward to the next. The lightest atoms in your body came from the universe's first minutes, but the heavier ones, the carbon, the oxygen, the iron, were made much later, deep inside stars. Stars are slow furnaces, fusing light elements into heavier ones across their long lives, building the richer atoms that the early cosmos could not make on its own. When great stars reached their ends, they scattered these new elements into space, seeding the clouds from which later stars, planets, and living things would form. So you are made of two beginnings at once, the hydrogen of the universe's first minutes, and the heavier atoms cooked in stars that died long before the sun. Every breath you take draws on that double inheritance, a body woven from the dawn of the cosmos and from the quiet deaths of ancient stars. To understand the beginning, scientists also look in the other direction, not outward to galaxies, but inward to the tiniest pieces that make up everything. Matter is built from a small family of fundamental particles, far smaller than atoms, governed by the soft, uncertain rules of the quantum world. In the universe's first instant, these particles and their forces were the whole story, swarming in the early heat before any atom could form. By studying them in great machines that gently recreate a trace of that early energy, we learn what the cosmos was like when it was unimaginably young. So the largest question, how it all began, leads us to the smallest things there are, and the two ends of the scale quietly meet in the beginning. One of the deepest comforts in all of science is that the laws of nature appear to be the same everywhere we look, from this room to the farthest galaxy. The light from distant suns shows the same elements behaving in the same ways as here on Earth, across billions of years and billions of light years. This constancy is what lets us study the beginning at all. We trust that the rules holding today also held in the early cosmos, allowing us to reason backward. Whether those laws themselves had an origin or could differ in other universes is one of the gentle open questions we touched earlier in the night. But within our cosmos, the steadiness of the laws is a quiet marvel, a deep reliability woven through everything, holding the great story together. It is easy to feel small beneath such a vast cosmos, and in size we truly are. Yet smallness is only half the truth, and the gentler half is connection. Every atom in you was made in the beginning or in a star, shared from the same source as the mountains, the oceans, and the most distant galaxy. So you are not a stranger set apart from the universe. You are woven from its oldest stuff, kin to everything that has ever shone or drifted in the dark. To feel small in such company is not to be lonely. It is to belong to the largest family there is, stretching back to the very first light. Let that belonging settle softly over you tonight, the quiet knowledge that you are made of the cosmos and held within it now and always. We have traveled far tonight, from the expanding sky of today all the way back toward the first instant, and softly beyond into the realm of gentle ideas. We saw the afterglow that still surrounds us, the seeds that became galaxies, the great web, and the deep open questions that wait beyond the edge of knowing. And through it all ran one quiet truth. The beginning was not a thing apart from us. It is woven into our atoms, our light, and this very moment of rest. There is nothing left to reach for now, and nothing left to solve. The cosmos will hold its mysteries through the night, asking only that you sleep. So take one last gentle look back toward the start, then let it fade like a distant galaxy, and drift down softly into the warm, waiting dark. Every tale humans have ever told unfolds against a backdrop far older than the telling. The beginning of the cosmos came long before the first word, the first fire, the first dream. The light now reaching your eyes from the deep sky set out before the earth existed, before the sun, before any creature looked up and felt the first stir of wonder. So the question we have held tonight is older than language and older than memory, woven into the world long before there was anyone to ask it. And yet here you are, a late and gentle arrival in that ancient story, able to look back across nearly all of time toward the moment it began. There is a deep calm in that thought. You belong to a tale far larger than yourself, one that was unfolding in light and silence long before you, and will continue long after. We measure time by watching things change, a swinging pendulum, the turning of the earth, the slow drift of stars, the steady beating of a heart. Without change of some kind, time would have nothing to mark its passing and no way to be counted. Near the beginning, before there were stars or planets or any steady motion, there were no clocks of any kind. The only measure of time was how swiftly the young, hot cosmos transformed itself from one fleeting state into the next. So the time of the first instant is not really counted in seconds as we know them. It is measured by change itself, by how rapidly the early universe cooled, settled, and reshaped its own deepest rules. The further back we trace the story, the stranger time becomes. At the very start, near the wall where our equations grow quiet, our familiar sense of steady, even ticking may lose its footing and gently blur away. Some thinkers wonder whether time, as we experience it, only truly emerged once the cosmos had cooled and settled into its steadier, slower rhythms, that the smooth flow we take for granted is itself a late arrival. If that is so, then asking what happened in the moments before the first tick is asking for a clock that did not yet exist to do the measuring. The question gently dissolves the more closely we look at it. There is a soft and lovely mystery in that thought, that time itself may have a story, beginning along with the space and the light, woven into the same quiet dawn from which everything else arose. One more gentle rest before we near the end. Let every great idea grow distant and small, like galaxies seen from very far away, soft points of light in the calm. You have wandered to the edge of time and back tonight, and now there is nowhere left to go, only here, only now, only the slow rhythm of your breath. Let the whole vast story settle into a single quiet feeling of peace. The beginning is behind you, around you, within you, and it is gently letting you go to sleep. Tonight we have stood at the edge of the deepest question and looked honestly at both what we know and what we do not. Both turn out to be vast. We know the universe expands, that it began hot and dense, that its first light still surrounds us, and that its earliest ripples grew into every galaxy. We do not know for certain whether time itself began, whether the cosmos bounced, whether other universes drift beyond our own. Those doors remain softly open. To hold both at once, deep knowledge and deep mystery, is not a contradiction. It is simply the honest shape of standing at the frontier of understanding. And it is a comfortable place to rest. We have learned enough to marvel, and left enough unknown to keep the marvel alive for every night still to come. For its first few 100,000 years, the cosmos stayed a glowing fog, too hot for light to pass through. Then, as it cooled, something changed across the entire sky at once. The loose particles slowed enough to join into the first whole atoms. Suddenly the fog thinned, and the trapped light could finally stream outward in straight, free lines. Scientists call this the moment of last scattering, the instant the universe became transparent, like a morning mist lifting all at once from a wide, still valley. The light released in that moment is exactly the afterglow we detect today. It is a snapshot of the cosmos at the age of about 380,000 years. So the oldest picture we can ever take is not of the beginning itself, but of the day the universe cleared, the first morning when light learned how to travel. The question of the beginning is older than science and will likely outlast every one of us. It has passed from mind to mind across all of human history, and it is not done. Each generation carries it a little further, hands it on a little clearer, and trusts the next to carry it further still. It is a quiet relay run across the ages. There is peace in being one runner among so many. You need not finish the race tonight. You need only hold the question gently and pass it onward in the morning. So let it rest in you for now, warm and unhurried, the way a coal rests beneath soft ash, keeping its glow for whoever tends it next. The beginning will still be there tomorrow and the day after, waiting with endless patience for the next mind to look up and gently wonder. We have come a long way tonight, back through the expanding sky, past the first light, to the wall at the start of time, and softly beyond into the realm of gentle ideas. We met the bounce and the no boundary, the universe from nothing, the endless aeons, the many bubbles in their endless sea, none final, all beautiful. And we found again and again the same calm truth, that the beginning, whatever it was smooth and vast and is woven still into this present moment. There is nothing left to do now but rest. The story will keep telling itself in the dark above you, asking nothing, offering only its quiet, ancient company. So let the deepest story become a lullaby. The universe began long ago in light, and tonight it is easing you with great gentleness toward sleep. Here at the close, let every large thought grow soft and far away. The questions can wait, the cosmos can wait. There is only the quiet now and your slow breathing. Picture the first faint glow spreading through a young universe, gentle as dawn through a curtain, and let that light settle warmly behind your closed eyes. You are made of the beginning, held in its afterglow, resting in a cosmos that has been moving toward this peaceful instant for nearly 14 billion years. There is nowhere to go and nothing to reach. The deepest question has brought you here only to lay you down, calm and whole at the soft edge of sleep. So let go and drift. The universe began in silence and light, and into that same silence and light it now gently carries you all the way down into rest. Our journey is ending now. Here at the soft edge of the deepest question, there is nothing more to learn tonight and nothing more you need to do. Let the ideas drift away like distant galaxies, growing fainter, dimmer, until only a calm dark remains, warm with the faint glow of the first light. You are made of the beginning and held in its afterglow in a universe that has been easing toward this peaceful moment for nearly 14 billion years. Breathe slowly now, and let each breath carry you a little deeper toward sleep, the way the cosmos eases outward, gentle and unhurried and calm. Sleep well. The great story will keep itself through the night, and the universe will hold you softly all the way until morning. Good night. That ancient afterglow is almost perfectly smooth across the sky, but not quite. Within it lie faint ripples, places very slightly warmer or cooler than the rest. These tiny ripples are the most precious detail in all of cosmology. They are the seeds of everything, the gentle unevenness from which galaxies would one day grow. The warmer, denser spots had a little more pull over long ages. Their gravity gathered matter inward, and from those soft beginnings the great structures of the cosmos formed. So when we map the first light, we are reading a kind of baby picture of the universe, and within it, the faint outline of the galaxies that did not yet exist. It is a humbling thing to hold. Everything you have ever seen traces back to whispers of unevenness in a sea of light, set down before the first star ever shone. Go back further to the universe's first few minutes, and it was far too hot for atoms, but just right for forging the simplest building blocks of matter. In that brief, fierce window, particles collided and stuck, cooking the lightest elements out of pure energy, mostly hydrogen, with a generous helping of helium. This happened across the whole cosmos at once, in only a handful of minutes, before the expansion cooled things past the point where such forging could continue. The recipe it left behind is remarkably exact, and when we measure the oldest gas in the sky, the amounts of hydrogen and helium match the prediction beautifully. So the air of the cosmos was set in its first minutes. Nearly every hydrogen atom in your body, in every glass of water, was made in that early, fleeting warmth. Today, nature works through a small set of fundamental forces, gravity, and the forces that bind atoms and light. But in the first instant, they may have been woven together as one. As the early universe cooled, scientists think these forces separated one by one, like a single bright thread unwinding into several finer strands. Each separation marked a turning point, changing how matter and energy behaved, shaping the rules that the cosmos would follow ever after. We cannot watch this directly, but our theories sketch it as a series of gentle settlings, the universe finding its lasting habits as the heat eased away. It is a calming thought. The very laws that hold your atoms together tonight may have been one law once, in a warmth older than time as we measure it. The story grows strangest near the very start. Almost everything dramatic happened not in years or minutes, but in the first unimaginably small fraction of a single second. In that sliver of time, the universe may have changed more than it has in all the billions of years since. The pace of those first instants is hard for any mind to hold. We use the language of fractions so small they seem unreal. Split a second into a million, then a million again, and keep going far beyond that. And yet within that vanishing moment, the foundations of the entire cosmos were laid down, smooth and even ready for the long, slow unfolding to come. There is no need to grasp the numbers tonight. It is enough to feel the wonder that so much gentleness began in so brief a flash and has been calm ever since. Trace the film back to its earliest sliver, and our equations reach a place they cannot cross. We call it the Planck epoch, the first faint tick of cosmic time. There, the universe was so small and so dense that the rules of the very large and the rules of the very small both apply at full strength, and they do not yet fit together. It is as if two trusted maps overlap and disagree. Where they conflict, neither can be fully trusted, and so the Planck epoch stands as a soft wall in our knowledge. Beyond that wall may lie the true beginning, or something stranger still. We simply lack, for now, the single theory that could let us see across it clearly. So this is the honest edge of the known. We can stand at it tonight, lean gently toward the dark on the far side, and feel the calm of a question still unfolding. One of our best theories describes gravity and the shape of space across vast distances. It is wonderfully exact for stars, galaxies, and the bending of light. Another describes the tiny world of particles, where things are grainy, uncertain, and full of soft probabilities. It too is tested and trusted beyond almost any other idea. For nearly everything, these theories never meet, so they never argue. The very large and the very small keep to their own quiet corners of nature. But at the universe's start, everything large was also small, the whole cosmos pressed into a speck. There both theories must speak at once, and their voices clash. Uniting them into one calm theory of quantum gravity is among the great unfinished tasks of science. When it comes, it may finally let us peek across the wall of the beginning. If we trust one theory all the way back, it predicts a singularity, a point of endless density where space and time seem to lose all meaning. Numbers there run off to infinity. But infinities in physics are usually a sign not of a real place, but of a theory pushed past where it works. They mark the edge of a map, not a true cliff in the world. Most scientists suspect the singularity is such a sign. A deeper theory may smooth it away, replacing the sharp point with something gentler and more whole. So the dramatic image of everything crushed to nothing may be a placeholder, a note that says here our current understanding ends and a softer truth awaits. That is a restful thought. The beginning need not be a violent point. It may turn out to be calmer and stranger than our oldest equations could guess. It helps to remember that our theories are maps, not the land itself. A good map captures the shape of things, but it is never quite the same as the ground beneath your feet. When two maps disagree at the same spot, the land is still there, whole and untroubled. The confusion lives in our drawings, not in the world. So too with the beginning. Whatever truly happened, happened smoothly in its own way. The trouble is only in our equations, which have not yet been redrawn finely enough. This is why scientists feel hope, not despair, at the edge of the known. A disagreement between maps is a clue pointing toward a better map waiting to be made. Rest in that calm. The cosmos is not broken where our understanding ends. It simply keeps being itself, quietly, while we slowly learn to describe it. One of the great puzzles of the beginning is how smooth the cosmos turned out to be. The afterglow looks nearly the same in every direction to a remarkable degree. That is strange. Regions on opposite sides of the sky are so far apart that in the simplest picture they could never have shared warmth or settled into the same gentle balance. It is as if two distant ponds, never connected, somehow ended up at exactly the same temperature. Something must have linked them long ago before they drew apart. This smoothness is too perfect to be mere luck. It is a clue that the early universe passed through some shared gentling phase we have not yet fully described. So the very evenness that lets the night sky feel calm and whole is itself a riddle, one that points us toward an idea called cosmic inflation. There is a second puzzle, just as deep. The overall shape of space appears almost perfectly flat, balanced between curving inward and curving outward. This balance is delicate. In the simplest picture, the universe would have to begin almost impossibly close to perfect flatness to remain so flat after billions of years. It is like a pencil standing on its point and never falling, possible in principle but so finely tuned that it begs for an explanation. Both puzzles, the smoothness and the flatness, point in the same direction. They hint that the early cosmos did something dramatic to set these conditions in place. That single elegant idea, able to answer both riddles at once, arrived only a few decades ago, and it gently reshaped how we think about the beginning. Recall the faint ripples in the first light, the slightly warmer and cooler patches across the ancient sky. They are not random noise. They carry a deep message. Their sizes and patterns match, with striking precision, what a brief early burst of rapid expansion would have stamped onto the cosmos. The afterglow remembers it. In other words, the seeds of every galaxy seem to be the stretched-out echoes of something that happened in the universe's first vanishing instant. To read those ripples is to read a fossil of the beginning, frozen into light and spread across the whole sky for us to measure tonight. And the story those ripples tell leads us straight into the boldest chapter of all, the idea that the universe at its very start ballooned outward beyond all imagining. Rest here a while in the oldest light. It fills the room around you, faint and warm, a soft sea of radiation that has been traveling since before the first star. You need not picture anything precisely. Just feel in a gentle way that you are bathed in the glow of the beginning, held in its quiet warmth. Let your breathing slow to match its patience. The afterglow is in no hurry. It has all of time, and for this moment, so do you. In the early 1980s, scientists proposed a daring fix for the puzzles of smoothness and flatness. They called it cosmic inflation, and it changed the picture of the beginning. The idea is this: in the first tiny fraction of a second, the universe expanded not gently, but at a staggering exponential rate, doubling in size again and again. In that brief burst, a region far smaller than a single atom was stretched larger than anything we can picture, smoothing and flattening it in the process. Then, almost as quickly as it began, this furious expansion ended, settling into the calmer, steady growth that has continued ever since. Inflation is not the beginning itself, but a proposed early act of the story, one that, if true, gently explains why our cosmos looks the way it does. Picture a wrinkled sheet, then imagine it stretched outward by an enormous amount. Any wrinkle, no matter how sharp, is pulled so wide it becomes nearly flat and smooth. Inflation does this to the whole cosmos. Whatever roughness existed before is stretched until it almost vanishes, leaving the gentle evenness we still see in the afterglow. It also brings distant regions into agreement. Before inflation, they were close enough to share the same conditions. The great stretching only carried them far apart afterward. So the riddle of why opposite sides of the sky match dissolves. They were once neighbors settling together before being swept to opposite ends of the visible universe. In one elegant motion, inflation answers both the smoothness and the flatness puzzles, which is a large part of why so many scientists find it persuasive. Inflation does something even more wonderful. The tiny, restless quivers of the quantum world, present in any patch of space, get caught up in the great stretching. These quantum quivers, normally far too small to matter, are blown up to enormous size, frozen into the fabric of the cosmos as gentle ripples of density. Those ripples are exactly the warmer and cooler patches we read in the first light. The seeds of galaxies in this view are magnified whispers from the smallest scale of nature. It is a breathtaking bridge. The largest structures in the universe trace back to the tiniest flickers stretched across the sky in the first instant of time. So every galaxy, including our own, may be the grown-up echo of a quantum murmur, a soft uncertainty made vast and made lasting by inflation. An idea is only as good as its tests, and inflation made specific predictions about the pattern of ripples in the ancient afterglow before we could measure them well. When precise instruments mapped the first light in fine detail, the patterns they found matched inflation's predictions with remarkable closeness. The sizes of the ripples, their gentle balance across large and small scales, the near-perfect smoothness, all of it lined up with what inflation expected. This agreement is why inflation, though still an idea rather than a certainty, is taken seriously as the leading account of the universe's first instant. Science is still testing it, searching for finer signs and considering rivals, but for now, the afterglow seems to whisper that the early cosmos truly did balloon outward. What could make space itself expand so violently for an instant, then stop? The leading answer is a special kind of energy stored in a field that filled the early universe. A field in physics is simply a quantity that has a value at every point in space, like the temperature across a room, but woven into the fabric of nature itself. Scientists imagine a field, sometimes called the inflaton, whose energy at the start pushed space to expand instead of slowing it, like a hill the universe had to roll down. While the field sat high on its hill, its energy drove the great stretching. As it rolled gently down, the stretching eased, and ordinary cosmic history began. We have not yet identified this field for certain. It remains a thoughtful sketch, but a sketch that fits the data and points toward what we might one day confirm. Inflation could not last. The energy driving it had to be released, and when it was, that vast store poured out into a flood of particles and light. Scientists call this reheating. The cold, empty stretch left by inflation was refilled with warmth, becoming the hot, glowing cosmos we traced earlier in the night. So inflation hands the story off smoothly. It ends by lighting the fire of the early universe, setting the stage for the forging of elements and the first free light. This handoff matters. It connects the strange first instant to the well-tested history that follows, weaving the bold idea into the larger, calmer tale. From a single hill of energy, gently rolled down, came the heat, the light, and in time every star, a long unfolding from one quiet beginning. Inflation changes how we even ask about the beginning. If the universe ballooned outward in its first instant, then the true start lies tucked behind that great stretching. Whatever happened before inflation is hidden from us, smoothed and stretched beyond our view. Inflation is like a soft curtain drawn across the earliest moment. This is both humbling and freeing. It means the deepest beginning may be even harder to reach than we thought, and that there is room for many gentle possibilities. It also raises a striking question. Did inflation happen only once, in one place, or could it happen again and again, in regions we will never see? That question opens one of the most spacious ideas in all of science, and we will drift toward it gently before the night is through. It can be soothing to picture the cosmos as filled, not empty. Fields lie across all of space, present everywhere at once, even where there seems to be nothing. The field thought to drive inflation is one such presence, a smooth, invisible quantity that, in the first instant, held an enormous store of energy in its stillness. We are used to thinking of energy as motion or heat, but a field can hold energy simply by sitting at a certain value, the way a stretched spring holds energy while at rest. When that quiet energy was released, it did not vanish. It became the matter and light of the early universe, and eventually across long ages became us. So the space around you tonight is not a barren void. It is a calm fabric of fields, the same kind of fabric whose stirring may have begun the visible cosmos. No idea in cosmology is accepted lightly. Inflation earned its place by doing something rare, solving several separate puzzles with one simple, graceful stroke. It explains the smoothness of the sky, the flatness of space, and the gentle seeds of galaxies all at once, without needing a different fix for each. It also made predictions that later measurements confirmed, which is the highest praise any scientific idea can earn, to be tested and to pass. Still, good scientists hold it with open hands. Alternatives exist, and certain deep questions about inflation remain unanswered, waiting on future work. That balance, strong support paired with honest doubt, is science at its calmest and its best, and it is the spirit in which we wonder tonight. Inflation is powerful, but it is not the final word. It describes a dramatic early act, yet it does not by itself tell us how the universe began in the first place. Something had to set inflation going, to put the field high on its hill in a small patch ready to balloon. That deeper question lies further back still. So even our boldest tested idea leaves the very first moment veiled. It pushes the curtain back, but it does not lift it entirely away. This is not a failure. Each idea clears a little more of the dark and shows us more precisely where the next great mystery begins. And it is there, beyond inflation, that the truly open questions wait, the ones about whether there was a before which we turn to now. Let us linger in the long dark age, after the first light and before the first star, a vast calm shadow, full of slowly gathering clouds and deep untroubled stillness. There is nothing to see and nothing to do there, only the soft patience of a universe waiting in the dark for its first stars to kindle. Settle into that same calm dark. Let it be a place with no demands where you, like the early cosmos, may simply rest and gather quiet before the dawn. Here we reach the heart of the night's question. When we ask what came before the beginning, we quietly assume there was a before, a stretch of time waiting beforehand. But time may not work that way. Some of the deepest thinkers in physics have suggested that time itself began with the universe, leaving no earlier moment. If that is so, then asking what came before is a little like asking what lies north of the North Pole. The question sounds fine, yet there is simply no such place. This idea can feel strange at first, then oddly calming. There may be no missing chapter before the beginning, only the beginning with nothing lacking. We do not know if this is true, but it is one of the gentlest answers the cosmos offers, that the beginning was truly the start and needed nothing to come before it. The great thinker who offered this picture loved the image of the North Pole. Walk north as far as you can, and at the pole north simply runs out. You cannot go further north. Nothing is broken there. The world is perfectly smooth at the pole. It is only the direction north that gently ceases to have meaning once you arrive. Time near the beginning, in this view, behaves much the same. Travel back toward the start, and the very idea of earlier softly dissolves without any sharp edge or wall. So the beginning need not be a violent boundary. It can be a smooth place where time rounds off, the way the surface of the earth rounds off at its pole. It is a restful image to carry towards sleep, a beginning with no jagged edge, where the question of before simply fades, gentle as a horizon. This picture has a name, the no-boundary idea. It proposes that the universe has no sharp starting edge in time, the way a sphere has no edge anywhere on its surface. On a globe you can travel forever without falling off, because the surface curves back smoothly. The no-boundary idea gives time a similar gentle wholeness near the start. In this view, there is no first instant standing alone, no door slammed shut behind us. There is only a smooth rounding off where time and space blend softly together. It is a mathematical idea, hard to picture fully, and it remains unproven, yet it offers something rare, a beginning that is complete in itself, needing no before. Whether or not it proves true, it loosens the grip of the question. Perhaps the universe was never missing anything. Perhaps it was always quietly whole. To soften the sharp start, some physicists imagine that near the beginning time loses its strict one-way flow and behaves a little more like another direction of space. We move freely through space, forward, back, side to side. Time normally flows only one way, but in the extreme of the beginning, that difference may gently blur. If time near the start acts like space, then there's no single first moment, only a smooth surface with no special edge, the rounding off we pictured before. This blurring is a tool of mathematics more than a thing we could ever feel. Yet it hints that the rules we take for granted may bend near the deepest beginning. There is comfort in that flexibility. The cosmos may be far more supple at its roots than our daily sense of time could ever suggest. It is worth pausing to honor a small phrase that runs through all of this: we do not know. In science, those 4 words are not weakness. They are a kind of integrity. To say we do not know is to keep the question alive, to refuse a false answer, and to leave the door open for a truer one to arrive in time. Every idea we touch tonight, inflation, the bounce, the many universes, is held in that honest spirit. Some are well tested, others are thoughtful, careful guesses. Knowing which is part of the calm. We need not pretend certainty about the deepest beginning to feel wonder at how much we have already learned. So let the unknown be soft tonight. It is not a void to fear, but a quiet space where the next discovery is slowly taking shape. The beginning sits exactly where our finest theories meet their limits, which is why it is so hard to study and so tempting to wonder about. To go further, we likely need a deeper theory, one that unites gravity with the grainy quantum world into a single, calmer description of nature. Scientists are working on such theories now with names like quantum gravity, loop ideas, and strings, each as an attempt to draw the better map we spoke of earlier. None is finished and none is yet confirmed, but each offers its own gentle picture of what the beginning might truly have been beyond the wall of the Planck epoch. We will visit a few of these pictures tonight, not as final truths, but as beautiful possibilities offered to keep your wondering mind softly company. Imagine standing at the wall at the start of time, where our equations grow quiet. It is not a frightening place. It is simply the farthest our current understanding reaches. On this side of the wall lies a story we can tell with confidence. The expansion, the afterglow, the elements, the galaxies. It is a tale tested again and again. On the far side lies the deepest unknown, the true beginning, and whatever, if anything, came before. We lean toward it with curiosity, not dread. Every generation of scientists moves the wall a little further back. What seemed unknowable yesterday becomes measurable tomorrow, one careful step at a time. So we rest at the wall tonight, content. We have walked a long way back through time, and the view from here is vast, quiet, and deeply at peace. One of the boldest ideas asks whether the universe could have begun from nothing, no space, no time, no matter, simply emerging into being. At first, this sounds impossible. How could something arise from nothing? But in physics, the word nothing turns out to be far subtler than it sounds. The everyday nothing, an empty box, is not truly empty. It is filled with fields and faint quantum stirrings, never perfectly still, never quite at zero. So when physicists speak of a universe from nothing, they often mean from a quantum state with no ordinary space or matter, yet still governed by the laws of nature. That is a different, gentler claim, not magic from a true void, but a soft emergence from the deep rules that may underlie even space and time themselves. Let us linger on this surprising truth. Empty space is not empty. Even in the deepest void, far from any star, the quantum world keeps a soft, ceaseless flicker. Particles appear and vanish again in fleeting pairs too brief to grasp, borrowing a little energy and returning it almost at once. The vacuum hums with quiet activity. This is not a guess. Its faint effects have been measured in the laboratory. The stillness of empty space is, at the smallest scale, a gentle and endless stir. So the void is alive with possibility, and if the everyday void can flicker like this, perhaps a deeper kind of void could flicker an entire universe into being. There is something peaceful in it, that even nothing is never truly still, that the dark itself is quietly, endlessly humming with the seeds of what might be. Some physicists have wondered whether the whole universe could have arisen the way those fleeting particles do by a quantum leap from a state of no space and no time. In the quantum world, things can cross barriers they seemingly should not, slipping through by a soft trick of probability called tunneling. Tiny particles do it constantly. The idea is that a minute, closed bit of space-time could have tunneled into existence in just this way, then immediately begun to inflate and grow. It is a careful mathematical proposal, not a proven fact, but it shows that a beginning from a quantum nothing is at least thinkable within the laws we know. Whether or not it is true, it gently widens the question. The beginning need not be a thing that always was. It might be a quiet event that, in some sense, simply happened. The word nothing carries a heavy load in these ideas, and it is worth holding gently. In daily life, nothing means an empty space. In physics, even that is something. A deeper nothing might mean no space, no time, no matter, yet still the bare laws of nature, the quiet rules from which a cosmos could unfold. So the honest claim is rarely that the universe came from utter absence. It is that it may have come from a state far simpler and emptier than anything we can picture. This matters for clarity. The science does not pretend to conjure a world from sheer non-existence. It explores how little is truly needed for a beginning. And that is a soft and humbling thought, that the grandest thing of all, the entire cosmos, might rest upon almost nothing. Here is a quiet wonder that makes a beginning from nothing easier to imagine. the total energy of the universe may add up remarkably to nearly zero. All the matter and light carry positive energy, but gravity, the great gathering force, carries a kind of negative energy, pulling things together. These two may very nearly cancel. The vast store of stars and galaxies could be balanced by the deep negative energy of gravity, leaving a sum close to nothing. If the books truly balance, then bringing a universe into being need not cost anything overall. It could arise without breaking the great ledger of nature. It is a strange and beautiful symmetry, a cosmos full of light and matter, and yet when everything is counted, a gentle, perfect zero underneath it all. Pause now at the gentle wall where our equations grow quiet. There is no need to cross it tonight. It is enough to rest beside it in the calm of the unknown. Beyond it lies the deepest mystery, and on this side lies all we have learned. Between the two, there is a soft, still place, and you are welcome to linger there. Let the not knowing be easy. It asks nothing of you. Breathe slowly at the edge of the beginning, and let the wonder hold you without weight. Not everyone pictures the beginning as a true start. Another family of ideas suggests the Big Bang was not the first event, but a turning point, a bounce. In this view, an earlier universe may have been contracting, growing smaller and denser until it reached a limit and rebounded outward into the expansion we see. So the hot, dense state we call the beginning would be the floor of the bounce, the moment a long collapse turns smoothly into a long growth. If that is so, then there was a before, an entire earlier cosmos falling inward, whose final squeeze became our first instant. The story would not begin, it would continue. This is one of the most soothing possibilities of all, a universe with no sharp birth, only an endless rhythm of gathering in and easing out. The appeal of a bounce is that it can sweep away the troublesome singularity, the point where our equations break. Instead of crushing to nothing, the cosmos rebounds. Certain theories of quantum gravity suggest that when matter is squeezed past a certain density, a gentle repulsion appears, pushing back against the collapse. Like a ball that compresses and springs back, the universe in these models reaches a minimum size, then bounces outward without ever reaching infinite density. If true, the beginning was never a place where time stopped. It was a smooth bridge from a shrinking past to a growing future, with no broken edge. We cannot yet see across such a bridge, but the idea offers a calm alternative to the lonely singularity, a beginning that is really a quiet continuation. One family of ideas, sometimes called loop quantum cosmology, imagines that space itself is not perfectly smooth, but woven from unimaginably tiny threads or grains. When the cosmos is squeezed toward that finest grain, the weave resists. It cannot be compressed without limit, so a gentle outward push arises to halt the collapse. That push is what turns a contraction into a bounce. The fabric of space at its smallest scale simply refuses to be crushed away to nothing. It is a tentative idea, still being explored, but a hopeful one. It suggests the very graininess of space could be what saves the beginning from being a true singularity. There is comfort in imagining space as a soft, resilient weave, something that bends and rebounds rather than tearing, even under the weight of an entire universe. If a single bounce is possible, some thinkers ask, why only one? Perhaps the cosmos has bounced many times, expanding, slowing, contracting, and bouncing again. This is the idea of a cyclic universe, a vast, slow breathing, each cycle a long age of growth followed by a gathering inward, on and on through deep time. In such a picture, our Big Bang would be only the latest in a long series, and the universe would have no single birth, only an endless rhythm. Ancient cultures often imagined the cosmos as cyclical, turning forever. It is striking that modern mathematics can sketch a gentle version of that very old intuition. Whether or not it is true, the image is restful, a universe that breathes in and out across unthinkable spans, never truly beginning, never truly ending. Another bounce-like idea grows from string theory, which imagines that our familiar three dimensions of space might sit upon a vast, unseen sheet floating in a larger space. In this picture, there could be more than one such sheet, and if two sheets drifted together and gently touched, the energy of that meeting could ignite a hot beginning. Our Big Bang in this view would be the moment two great sheets brushed against each other, filling our world with warmth and setting the expansion going. It is a strange and beautiful image, entire universes as floating membranes, and a beginning born from their soft, slow collision in a hidden dimension. This idea, sometimes called the ekpyrotic picture, is unproven and bold, but it shows how richly imagination and mathematics can together explore the deepest start. One famous thinker offered a picture stranger and gentler still. He imagined the universe not bouncing but flowing, each cosmos giving way smoothly to the next. In the far, far future, after all the stars have died, and even the great black holes have faded, the universe would be nothing but a thin, cold sea of light. In such an empty, light-filled cosmos, he argued, the very notions of size and time lose their grip. Vast and tiny become indistinguishable, and a new beginning could form. So the cold, endless end of one universe might become, in this view, the hot, dense beginning of another, an unbroken chain of ages he called aeons. It is a poetic idea, debated and unconfirmed, yet deeply calming, an end that is also a beginning, and a cosmos that never truly stops, only turns gently onward. It is worth a soft pause to notice how often the newest science echoes the oldest stories. Many ancient peoples imagined a cosmos of endless cycles, of worlds without final end. Modern bounce and cyclic models are not those myths, and they rest on careful mathematics rather than legend, yet they touch the same deep human intuition of return. This is not proof of anything. It is only a quiet reminder that the wish to see the beginning as part of an endless rhythm is very old and very human. Perhaps that intuition will prove right, or perhaps the universe truly had a single start. Either way, the longing to know is a thread that links every generation. So as you rest, you join a line of wanderers stretching back through all of time, each one looking up, each one asking the same gentle question into the dark. As soothing as a bouncing cosmos sounds, it carries its own deep puzzles. Chief among them is the question of order and why our universe began so smooth and so calm. A long contraction tends to grow lumpy and chaotic, not smooth. So a successful bounce must somehow deliver a gentle, even universe on the far side, and that is hard to arrange. Different models try different solutions, and none has yet won the day. The bounce remains a hopeful sketch, awaiting a clearer theory and ideally a testable sign. This is the honest state of things, a beautiful possibility, not a proven fact, standing alongside inflation and the no-boundary idea as a gentle contender. And that crowd of contenders is itself a comfort. The beginning is rich enough to hold many ideas at once, each lighting the dark from a slightly different angle. By now we have gathered several pictures of the beginning, a smooth rounding off of time, a quantum emergence from nothing, a great bounce, an endless chain of aeons. They cannot all be the full truth, and perhaps none is, yet there is no need to choose tonight, and no harm in letting them rest side by side in the mind. Science will slowly sort them, gathering evidence, ruling some out, refining others, until a clearer story emerges. That work may take generations, and that is all right. For now, each idea is a different doorway opening onto the same vast dark, and each is beautiful in its own quiet way. So carry them lightly, like a handful of soft stones. You need not decide which is real. You need only rest among the possibilities, calm and unhurried. Recall the idea that the early universe inflated. Some versions suggest that once inflation starts, it may never fully stop everywhere. It keeps going in vast outer regions forever. In this picture called eternal inflation, our cosmos is a single bubble that stopped inflating and settled down, while inflation rages on in the space beyond. And if one bubble can form, so can others, countless bubbles, each a universe of its own, popping into calm within an endlessly stretching sea. So our Big Bang would be the beginning of our bubble alone, one quiet start among an unimaginable host of others scattered through the eternal stretch. It is a staggering thought and an unproven one, but it flows naturally from inflation, which is part of why so many cosmologists take the many-universe idea seriously. Picture a vast, dark ocean that never stops expanding here and there. Soft bubbles form, each one calming into a universe with its own stars and its own long history. Each bubble is sealed within the endless stretching, drifting ever farther from the others, so that the space between them grows faster than any light could cross. This means the other universes, if they exist, lie forever beyond our reach. We could never visit them, never see them, never receive a single signal from their shores. That distance is humbling, but also gentle. The other worlds, real or not, ask nothing of us. They simply drift in the great sea as we drift in ours. And our bubble, our universe, is enough, vast beyond counting, full of light, and home to every star you have ever seen rising over the quiet earth. If many universes exist, a deeper wonder follows. Perhaps they do not all share the same laws. The strengths of forces, the masses of particles might differ from bubble to bubble. In some, gravity might be stronger, or atoms unable to form, or stars never able to shine. Most might be barren, with no chance for anything like us to arise. Ours, by contrast, has just the right balance for stars, planets, and life. A balance so fine it has long puzzled and amazed those who study it. If countless universes try countless laws, then it is no surprise that we find ourselves in one of the rare welcoming kinds. We could hardly find ourselves anywhere else. This is a careful, debated line of thought, not a proven answer, but it offers one gentle way to understand why our cosmos seems so quietly suited to our being here. It is fair to ask whether a many-universe idea is even science if the other universes can never be seen. That question is taken seriously and debated with care. The hope is that the idea might still be tested indirectly, through subtle marks in our own sky, or as a natural prediction of theories we can check in other ways. For now, the many universes remain a possibility flowing from well-motivated physics rather than a thing we have observed. That distinction is held honestly. So we treat it as we treat the bounce and the no-boundary idea, as a beautiful sketch on the far side of the wall, awaiting evidence that may or may not come. There is a quiet freedom in that. We can wonder at the possibility of other worlds without needing to believe in them, holding the thought as softly as a dream. Whether there is one universe or countless, our own remains astonishing. It is large enough to hold 100 billion galaxies, each with 100 billion stars or more. Within that vastness lies a single quiet planet, warmed by an ordinary star, where the cosmos has somehow learned to look back upon itself and wonder. That is the strangest fact of all, that a universe begun in faceless heat and light could, after billions of years, give rise to minds soft enough to ask where it came from. So even if ours is one bubble among an endless sea, it is the one that holds you and that makes it precious beyond any counting. Tonight, in this one world among the possible many, you are resting beneath the afterglow of its beginning. That is a gift no number of other universes could lessen. Here is a fact to carry gently toward sleep. The simplest atoms in your body, the hydrogen in every drop of your blood and water, were forged in the first minutes of time. They were made in the early warmth we spoke of long ago tonight, before the first star, before the first galaxy, in the universe's opening moments. So you are not separate from the beginning. A part of you is as old as the cosmos itself, carried down through 14 billion years to this quiet bed. The same expansion, the same first light, the same gentle ripples that grew into galaxies also led, by a long and winding path, to the warmth of your own breathing. To rest tonight is to hold a small piece of the beginning, alive and at peace. The universe did not only make you in a true sense, it is resting within you now. Drift for a moment among the imagined bubbles, each a universe of its own, scattered through an endless, stretching sea. There is no need to believe, only to wonder. Picture them softly, like lanterns floating far apart in a vast dark water, each glowing with its own private sky forever beyond reach. And then let them fade, return gently to your own bubble, your own warm world, your own quiet bed, which is more than enough and far closer than any star. It is worth marveling that we know any of this. Everything we have learned about the beginning was read from faint light gathered by careful instruments. From the slight reddening of distant galaxies, we found the expansion. From the gentle afterglow, we found the first clear morning and the seeds of every galaxy. From the amounts of the lightest elements, we confirmed the first few minutes. Each clue is faint, yet together they tell a story tested in 100 separate ways. That a species on one small planet could piece together the history of an entire cosmos from whispers of ancient light is a quiet triumph worth honoring. So even where the deepest beginning stays veiled, we have already come astonishingly far, and we did it by listening closely to the soft voice of the sky. To read the beginning, we built remarkable eyes, great telescopes on mountaintops and drifting above the air, gather light that left its source nearly 14 billion years ago. Special instruments map the faint afterglow across the whole sky, measuring warmth differences finer than a few parts in 100,000, a stillness almost beyond belief. Other detectors hunt for the lightest particles and the gentlest signals, each one a thread that, when followed, leads a little closer to the universe's first instant. None of this is loud or sudden. It is the slow, careful work of many hands across many years, each measurement adding one more soft line to the story. And the tools keep improving. With each new eye we open on the sky, the wall at the start of time may ease back a little further into the light. The beginning is not a closed book. Scientists are searching now for faint signals that could tell inflation, the bounce, and other ideas apart from one another. Some look for a subtle ripple that inflation might have left in the fabric of space, a gentle trembling woven into the oldest light that a bounce would not produce. If such a sign were found, it would be a soft message from the universe's first instant, helping us choose among the beautiful possibilities we have gathered tonight. And if it is not found, that too would teach us, nudging us toward the bounce, or the cyclic picture, or something no one has yet imagined. Either way, the question is alive and moving. The beginning we cannot quite see tonight may grow a little clearer in the years that quietly lie ahead. Step back for a moment and feel the scope of it. A century ago, we did not even know the universe was expanding or that other galaxies existed beyond our own. In a single lifetime, we traced the cosmos back nearly to its first instant, mapped its baby picture, and weighed the elements made in its opening minutes. We learned that space itself stretches, that the first light still surrounds us, and that the seeds of galaxies were sown before any star had shone. These are not small things. They are among the deepest truths any creatures have ever uncovered, won by patience and wonder rather than haste. So even with the final beginning still veiled, we have already journeyed an astonishing distance into the dark, and the journey is gentle and far from over. There is a reason the question of the beginning stirs us so deeply. It is not only about the cosmos out there, it is about where we and everything we love came from. To ask how the universe began is, in a quiet way, to ask how we came to be here, how warmth and light, and eventually thought arose from the first faint glow. That is why the question has lived in every culture, told in temples and around fires long before telescopes. It is the human longing to know our own origin. Science does not replace that longing. It honors it, answering what it can and admitting what it cannot, with the same wonder that first asked the question. So as you drift tonight, know that your curiosity is ancient and shared. You are wondering the oldest wonder in the calm company of all who came before. It might seem unsettling that the deepest beginning stays unknown, but there is a soft comfort in an open question. It means the wonder is not yet used up. A finished answer is a closed door. An open question is a window left ajar, letting in the cool night air of possibility, with more to discover by morning. The universe has given us just enough to marvel at, and held just enough back to keep us looking. That balance is itself a kind of gift. So you need not feel the lack of a final answer as an emptiness. Feel it instead as room for tomorrow's discoveries and for tonight's gentle dreaming. Rest then in the unfinished. The greatest stories are the ones still being told, and this one will go on telling itself long after you have fallen asleep. If the universe teaches one lesson tonight, it may be the value of slowness. It has unfolded over 14 billion years, never rushing, never anxious, simply being. Galaxies turn once every few 100 million years. Stars live for ages beyond counting. The expansion eases outward at a pace no eye could ever catch in a lifetime. Against such patience, the worries of a single night grow small and soft. The cosmos has all the time there is, and a little of that calm can be yours. There is nothing you must finish before you sleep. The universe will keep expanding. The afterglow will keep arriving, whether you watch or whether you rest. So let yourself match its pace for a while. Breathe slowly, like a turning galaxy. Let the great unhurried dark hold you and ease you gently down toward sleep. Consider, as you settle, the journeys that light makes. The afterglow reaching the earth tonight set out when the universe was barely a few 100,000 years old. For nearly 14 billion years it has crossed the widening dark, untouched, unhurried, carrying its faint message all the way to this single quiet moment. And starlight, too, has traveled far. The glow from distant galaxies left long before the sun was born, only now arriving to brush against our watching eyes. So every time we look up, we look back. The night sky is not a picture of now, but a deep and gentle layering of the past, all the way to the beginning. To rest beneath such light is to be touched by the most unhurried travelers there are, messengers from the dawn of everything, arriving at last in the dark of your room. It can feel as though the beginning lies impossibly far away, lost in deep time, but in truth, a trace of it surrounds you in every direction right now tonight. The afterglow of the first light fills all of space, passing through the air, through the walls, through your resting body, gentle and ceaseless. So the beginning is not only a moment long behind us, it is also a soft presence woven through the present, the oldest light still quietly arriving. In that sense, you have never been far from the origin of everything. It has been with you all along, faint as a whisper, steady as the dark. Let that nearness be a comfort. The vast beginning is not distant or cold. It is close and quiet, and folded gently into this very moment of rest. Beneath all the science lies a question even softer and deeper, not how the universe began, but why there is anything at all, rather than simply nothing. That question may lie forever beyond physics, in the realm where wonder turns to quiet awe, and it is a fine place to rest with no answer required. For tonight, it is enough that there is something, that there is light and warmth and a cosmos vast enough to hold one drowsy mind asking after its source. The mere fact of existence, so easy to overlook, is perhaps the largest marvel of all. You are here, the universe is here, and that by itself is astonishing. So let the deepest why remain unanswered and untroubling. Rest simply in the gift of being in a cosmos that, against all odds, chose to be at all. Some find the great questions frightening, the vastness, the unknown, the sheer scale of time and space. But wonder need never become fear, and tonight it will. The cosmos is not cold toward you, nor cruel. It is simply large and old and quiet, and you are a part of it, made from its oldest matter and warmed by its light. To feel small beneath the stars is not to be diminished. It is to be held within something immense and gentle, the way a single note is held within a long, slow song. So let the bigness be soft. Let the mystery be kind. There is nothing in the dark above you that wishes you anything but rest. Breathe out the worry, and breathe in the calm. The universe that began so long ago has been moving toward this peaceful moment all along. After the first light was set free, the universe entered a long, dark age. The glowing fog had cleared, but no stars had yet formed to light the great new emptiness. For many millions of years, the cosmos drifted in shadow, vast clouds of hydrogen and helium, gathering slowly under gravity, waiting to become the first stars. It was a time of deep stillness, the universe holding its breath in the dark, the seeds from the beginning slowly drawing inward toward their first ignition. Then, at last, the first stars kindled, and light returned to the cosmos for good. A second dawn, born from the gentle work of those long, quiet ages. There is something restful in that dark age, that long, quiet pause between the first light and the first star. The universe, too, knows how to wait in the quiet before the glow. It is worth tracing one last gentle time, the path from the beginning to the sky we know. It started smooth and even, with only the faintest ripples of unevenness. Those ripples, the seeds from the first instant, pulled matter slowly together. Over long ages, the densest patches gathered into clouds, and the clouds into the first stars. Stars clustered into galaxies, galaxies into great groups, and across billions of years the smooth early cosmos grew into the rich, structured sky above us. So the whole grand architecture of the night, every galaxy, every constellation, traces back to whispers of unevenness set down in the universe's opening moment. From near-perfect smoothness to a sky brimming with light, that is the long, calm journey of the cosmos, and the journey that in time made the place where you rest. Pause on the wonder of it. Everything you have ever known, every sunrise, every ocean, every face you love, unfolded from one small, hot, smooth beginning. The same first instant that set space expanding also led, by an unbroken chain, to the earth beneath you and the breath moving softly in and out of your chest. Nothing was added from outside. The cosmos simply unfolded what was already present in its opening, the way a vast tree unfolds from the quiet promise of a seed. So you are not a stranger in the universe. You are one of its unfoldings, a way the beginning continues, 14 billion years on, in the warmth of a single life. Let that wholeness settle over you. You belong to the story of the beginning as surely as the farthest galaxy, and tonight that story is gently carrying you to sleep. It is fair to wonder how anyone could measure the age of the universe. The number, near 14 billion years, did not come from a guess. It came from several careful methods that quietly agree. One way reads the expansion itself. By measuring how fast distant galaxies recede and how far they lie, we can run the growth backward and estimate when it all began. Another way reads the oldest stars. The most ancient stars we find are billions of years old, and the universe must of course be older than anything that lives within it. A third way reads the fine details of the afterglow, whose ripples encode the cosmos's age with surprising precision. All three methods land in the same gentle range. When separate paths, using different clues, arrive at the same answer, confidence grows. The great age of the universe is one of the most carefully checked numbers in all of science. The discovery of the first light was not the result of a grand search. Two engineers, testing a sensitive antenna, kept finding a faint hum they could not explain or remove. They cleaned the antenna, checked every wire, and ruled out every ordinary source. Still, the soft hiss remained, arriving evenly from every direction in the sky at once. What they had stumbled upon was the afterglow of the beginning, the oldest light foreseen years earlier by others, now found by chance in a quiet field. That faint hum, once a nuisance, turned out to be one of the greatest discoveries ever made, a direct echo of the universe's early warmth. It is a lovely reminder that the cosmos sometimes hands us its deepest secrets when we are simply paying close attention, even to a sound we wish would go away. The clearest sign of the expanding universe is written into the color of distant light. As space stretches, the light traveling through it stretches too, shifting toward the red. This gentle reddening is called redshift. The farther a galaxy lies, the longer its light has traveled, and the more the growing space has stretched its waves. It is not that the galaxies are simply moving away through space like cars on a road. The very fabric between us and them is lengthening as the light crosses it. By measuring how much a galaxy's light has reddened, we can tell how much the universe has grown since that light first set out on its long journey. So the colors of the deep sky are a kind of record. The reddest, faintest galaxies show us the universe as it was when it was far younger and smaller. Here is a question so simple it is easy to miss. Why is the night sky dark? If the universe were endless and unchanging, every line of sight would end on a star and the night would blaze. Yet the night is mostly black, with stars scattered like sparks across a deep dark. That darkness is itself a quiet clue about the nature of the cosmos. Part of the answer is that the universe has a finite age. Light from the most distant reaches has not yet had time to arrive, leaving much of the sky dark. And part is the expansion. The stretching of space reddens and dims the most distant light, easing it gently out of view and deepening the darkness between the stars. So the calm dark of night is not empty of meaning. It softly tells us that the universe began and that it grows, written in the very blackness above your bed. Not long ago, scientists held two rival pictures of the cosmos. One said the universe began hot and dense and has changed ever since. The other said it had always looked much the same. The steady picture was elegant and had thoughtful supporters. It imagined an eternal cosmos with no beginning at all, gently making new matter to fill the growing space. For a time, no one could be sure which view was right. Both fit the early evidence, and the question of a true beginning hung gently in the balance. Then the afterglow was found. An eternal, unchanging universe had no reason to glow with the warmth of an early furnace, but a hot beginning did exactly as foreseen. So the soft hum from every direction settled the matter. The universe, it seems, truly had a hot, dense beginning, and the long debate eased quietly to its close. There is more to the universe than the matter we can see. Galaxies spin and cluster as though held by far more mass than their visible stars could ever provide. Scientists call this unseen substance dark matter. It gives off no light, yet its gentle gravity shapes the motion of galaxies and the great structure of the cosmos. We have not yet caught a single piece of it directly, but its pull is felt everywhere in the bending of light and the turning of galaxies alike. In the story of the beginning, dark matter plays a quiet but essential role. Its gravity helped gather ordinary matter into the first clumps and clouds. So an invisible scaffolding seems to underlie the visible sky, holding the galaxies in their slow dance, present everywhere, yet hidden softly from our eyes. Recall the faint seeds in the afterglow, the slightly denser patches in the early cosmos. On their own, ordinary matter might have gathered too slowly to form galaxies in time. Dark matter, feeling only gravity and not the pressure of light, could begin clumping earlier and faster, building deep wells of pull while the cosmos was still young. Ordinary matter then flowed into those waiting wells, gathering where the dark matter had already pooled, and there the first stars and galaxies slowly took shape. So the visible cosmos may have grown within an unseen framework, like frost forming along a hidden lattice, taking the shape of something we cannot directly see. It is a humbling thought to carry towards sleep. The bright galaxies above us may be the visible bloom upon a vast, quiet scaffolding of the dark. For most of the universe's life, gravity slowed its expansion, gently tugging all the matter back toward itself. The growth was real, but it was easing, age by age. Then, a few decades ago, careful measurements revealed something unexpected. In recent cosmic times, the expansion has not been slowing at all, it has been speeding up. Some unknown influence woven through empty space appears to push the cosmos to grow ever faster. Scientists call it dark energy, though the name only marks our uncertainty. Dark energy seems to make up most of the universe, yet we understand it least of all. It is among the deepest open puzzles in the science of the cosmos. So even now, the universe is gently quickening its outward drift, carried by something unseen, a mystery as alive today as the question of how it all began. A natural question about the expanding universe is simply, where is the center, the spot where the beginning happened and from which everything flies outward? The surprising answer is that there is no center and no edge either. The Big Bang did not happen at one point in space. It happened across all of space at once. Imagine dots on the surface of a balloon being inflated. Every dot sees the others moving away, and no dot is the special center. They all drift apart together. The cosmos is like that in 3 dimensions instead of 2. From every galaxy, all the others appear to recede, and each could imagine itself the still center of all. So you are not far from where the beginning occurred. In a real sense, it occurred right where you are resting, and at every other place, in the same first instant. The universe we can observe is vast, tens of billions of light years across, yet it is almost certainly only a portion of a far larger whole. Beyond our horizon, where light has not had time to reach us, the cosmos likely continues, perhaps for an unimaginable distance, perhaps without any end at all. We can never see those farther reaches directly, but the smoothness and flatness of our own region hint that the larger universe is much the same, on and on. It is a little like standing in fog and seeing only the nearest trees. The forest surely extends past your sight, even though the mist hides it gently from view. So the part we can study is a single quiet clearing in a far greater wood. The beginning belongs to all of it, most of which lies forever beyond our gaze. Because looking far away means looking back in time, our greatest telescopes can glimpse the cosmos as it was when it was very young, soon after the first stars lit. New eyes in space now gather the faint, stretched light of some of the earliest galaxies, formed only a few 100 million years after the beginning. These early galaxies are small and strange, still finding their shape, glowing softly across an almost unimaginable gulf of space and time before reaching us. Each one is a messenger from the cosmic dawn, showing us how the smooth early universe began at last to gather into the bright structures we know. So we are living in a remarkable age, when the universe's first chapters are slowly coming into view. Read in the faintest light from the deepest dark. Light is not the only messenger from the cosmos. Space itself can carry gentle waves, ripples in the fabric of reality, set off by the most powerful events. When great masses move sharply, far away, they send out faint stretches and squeezes of space that travel outward at the speed of light like ripples on a pond. These gravitational waves are extraordinarily soft by the time they reach us, shifting distances by less than the width of an atom, yet we have learned to feel them. With these waves, we can listen to the cosmos rather than only watch it, sensing events that give off no light at all, deep in the silent dark. And there is hope that the beginning itself sent out such ripples, a faint trembling from the first instant, still spreading gently through space toward us. If cosmic inflation truly happened, it should have shaken space in its first instant, sending out a faint background of gravitational waves from the very beginning. Those earliest ripples would be far too soft to feel directly, but they might have left a subtle swirling mark woven into the oldest light of the afterglow. Scientists are searching the first light with great care for that faint twist, a delicate signature that would point clearly toward the great early stretching. Finding it would be a soft message from the universe's opening moment, helping to separate inflation from the bounce and the other gentle ideas we have gathered. So even now, watchers around the world are listening for the faintest tremor of the beginning, a whisper that may one day ease across the wall of the start. Here is a quiet mystery hidden in plain sight. Time seems to flow only one way. We remember the past, never the future, and a fallen cup never gathers itself whole again. The laws of physics, oddly, hardly notice the difference between forward and back, yet our experience has a clear direction, an arrow pointing always from past to future. The leading explanation lies in a quantity called entropy, a measure of how spread out and disordered things are. Entropy tends to grow, never to shrink, as time goes on. Cups shatter and never reassemble because the scattered pieces are far more disordered than the whole. The arrow of time is the slow, steady rise of disorder, and this arrow points back to the beginning, which must have been a place of remarkable order, a low, smooth start from which all the rich disorder since has grown. This raises a deep and lovely puzzle. For the arrow of time to point as it does, the early universe must have begun in an exceptionally orderly, low disorder state. That is strange, because disorder is, in a sense, far more common than order. A smooth, calm beginning is a special and finely arranged way for a universe to start. Why the cosmos began so orderly is among the most profound open questions in all of physics, tied closely to the mystery of the beginning itself. Some hope that inflation, or a bounce, or a deeper theory will explain it, showing why the start was smooth and low in disorder, rather than wild and chaotic. So the simple fact that you remember yesterday but not tomorrow traces all the way back to the gentle orderliness of the universe's very first moment. Just as we wonder how the cosmos began, we can wonder how it might end. With the expansion speeding up, the leading picture is one of slow, gentle fading. Across unimaginable ages, the galaxies will drift ever farther apart. the stars will burn out one by one, and the sky will grow slowly darker and quieter. In the deepest future, even the longest-lived stars will fade, and the cosmos will cool toward a vast, calm, near-empty dark, a long, soft winding down. It is not a violent end, but a quiet one, an easing into stillness over spans of time that dwarf the entire history that has passed so far. And in a few bold ideas, that cold and quiet end might even become the seed of a new beginning, the close of one age touching gently the start of another. Among the strangest ideas in modern physics is the thought that all the depth of the universe might, in some sense, be written upon a distant surface, like a hologram. In a hologram, a flat surface holds all the information needed to build a full, three-dimensional image. Some theories hint the cosmos may work in a similar way. In this view, the rich, deep space we move through could be a kind of projection of information stored on a far-off boundary, subtle and unseen. It is a careful mathematical idea, explored to help unite gravity with the quantum world, and it remains far from proven, a beautiful possibility, gently held. If it were true, it would change how we picture the beginning, and even what space and time most deeply are. For now it is one more soft wonder among many. We often think of deep time as the long past behind us, but the future stretches even further across spans so vast that the whole age of the cosmos so far is only a first breath. If the universe fades slowly, its quiet later ages will last far longer than everything that has happened from the beginning until now, almost beyond the reach of any number. In that deep future, the cosmos will be calmer and emptier, a soft, dark sea where the bright, busy era of stars is only a distant, early memory. There is a strange peace in that thought. The loud, bright chapter we live in is brief and precious, set against an immense and gentle quiet still to come. So the beginning and the far end are bound together by the same slow river of time, and you are resting somewhere near its bright and early bank tonight. Set against the great span of cosmic time, a single human life is brief beyond measure, a soft flicker in a story almost 14 billion years long. And yet that flicker is where the wonder lives. The universe spent ages of dark and light and slow gathering to produce a mind able to look back and ask how it began. So you are not small in the way that diminishes. You are a rare, brief place where the cosmos becomes aware of itself, if only for a quiet lifetime. That is reason for gentleness, not for worry. To be a conscious moment in such a long, vast story is a gift the early universe could never have foreseen. Rest, then, as a treasured instant in an immense and unfolding tale, one quiet evening among the countless the cosmos has slowly made possible. Before we turn toward sleep, let us gently gather what we have found. The universe is expanding. It began hot and dense. Its first light still surrounds us tonight. Its earliest ripples grew with the help of unseen matter into galaxies and stars. Its expansion now quickens, carried by an energy we have only begun to name. And at the deepest start, where our maps grow quiet, we hold many gentle ideas, a smooth rounding of time, a quantum emergence, a bounce, an endless chain of age. None is yet certain, and that is no flaw. It is the honest shape of standing at the frontier, with much learned and much still beautifully unknown. So the pieces form a vast, unfinished picture, glowing softly at its edges. It is enough to marvel at tonight, and gentle enough to fall asleep inside. In the first moments, matter and its mirror twin, antimatter, were made in nearly equal amounts. When the two meet, they vanish together in a flash of pure light. Had they been made in perfect balance, they would have wiped each other out completely, leaving a cosmos of light and nothing else. No stars, no planets, no you. But the balance was very slightly off. For every billion pairs that annihilated, a single extra speck of ordinary matter seems to have remained behind. From that faint surplus, 1 part in a billion, came every galaxy and every grain of sand. The visible universe is the small remainder of a vast early cancellation. Why the scales tipped even by that whisper is still an open question, yet without that tiny imbalance, there would be no one here to wonder about it. On the largest scales, the galaxies are not scattered evenly. They gather along immense glowing threads, with great quiet voids of near emptiness between them. Scientists call this the cosmic web. Long filaments of galaxies stretch across hundreds of millions of light years, meeting at dense knots and clusters. This vast structure grew directly from the faint seeds in the first light, where the early universe was a touch denser matter gathered, where thinner the voids opened. So the grandest pattern in all of nature is the grown-up echo of the gentle ripples we read in the afterglow, magnified across unthinkable distance. To picture the web is to see the whole cosmos as a single slow structure, a soft lattice of light and shadow spun from the unevenness of the beginning.